Hello everyone, welcome to another of our short sessions where this session will be focused on understanding the exponential distribution. So on the board I have the cumulative distribution function for the exponential distribution, which is given by 1 minus exponential raised to negative lambda x, where our parameter is given as lambda. So the first thing I want us to do for the exponential distribution is from its CDF, its cumulative distribution function, let's find out how we obtain its PDF. What is the probability density function for the exponential distribution? Now, as already mentioned in class, we know that the PDF, to get the PDF of a function from its CDF, the cumulative distribution function, we differentiate the CDF with respect to the variable, in our case d over dx of f of x here, where f of x is given by 1 minus exponential raised to negative lambda x. So the solution to this will give us our PDF. Now if we differentiate with respect to x1, 1 is a constant, so if we differentiate it with respect to x, it will give us 0, minus, if we differentiate exponential negative lambda raised to x with respect to x, what happens is we have to differentiate the power there, where if you differentiate negative lambda x, you have negative lambda will drop down, so that you will remain with exponential negative lambda x, and differentiating the exponential function remains the exponential function, which therefore means that 0 minus lambda exponential minus lambda x, this here would become positive, so that our answer becomes simply lambda exponential minus lambda x, and that is the PDF of an exponential distribution, where x is greater than 0. So that's how we get our probability density function from the distribution function of the exponential distribution. So now that we have the PDF alongside the CDF, let's look at another thing that we require from the exponential distribution. Which is the mean for an exponential distribution. So how do you obtain the mean for an exponential distribution? Now, the mean for an exponential distribution is first of all given by expected value of x, which will be 1 over its parameter. So the question is, can we derive the mean given the probability density function? And the answer to that is yes, because we know that when you need expectation of x, where x is from a particular distribution, to get this, we integrate, if it is a continuous function, x times the probability density function with respect to x for all values of x. So for the exponential distribution, we would need to integrate x times its PDF, which is lambda exponential minus lambda x dx for all values of x, where the smallest value for x is 0 and the largest one is infinity. So then we need to make sure that this expression will give us so the first thing we note from our integral is we are differentiating with respect to x, and therefore we have a constant that we can remove from within the integral. This means that our expression can be expressed as lambda so that is the integral that we need to find, where we need to integrate therefore just lambda times exponential raised to negative lambda times x from the limits of 0 to infinity, and then multiply it by lambda to get the expected value of x. Now, this integration you'll have to, the formula within the integration is a product of two different functions, which means the best way to move from here is to integrate by parts. And on a previous session, we learned that integration by parts formula ideally means that if you can split your integral into the form u dv, then the integration result will be equal to u v minus integral of v du. So we'll use this result here to help us integrate that formula within that. So our expected value of x therefore becomes, we have the lambda that's outside, now the integral of that within there. So how do we get the integral within there? So let's start with, first of all, I need to figure out what my u is and what my dv is for me to be able to move forward. So if I choose my u as x, and then I choose my dv, I choose my u as x and choose my dv as everything else, then I can be able to get what du is, and I can be able to get what v is from those two. So let's find out what that will be. So in our case, if I choose my u to be x, then my du is going to be dx, and if I choose my dv to be equal to exponential minus lambda x dx, then my v, which will be obtained by integrating both sides, will be equal to exponential minus lambda x negative over lambda. So that's therefore, for this integral within that, I know now if I integrate u dv given by x exponential negative lambda x dx, I will have u times v, meaning x times exponential negative lambda x over lambda, so that I have negative x exponential minus lambda x over lambda minus the integral of v du, the integral of v du, which is the integral of negative exponential minus lambda x over lambda dx. And remember, the limits still remain from 0 to infinity, and the portion that you have already integrated, we now say the limits still remain from 0 all the way to infinity, and therefore my integration formula has been simplified to that level. So let's move on to the next step. Now, after using integration by parts, I still have another integration that I have to take care of, which is this integration. And this integration can be taken care of because there is a constant within it which I can remove, and this negative can also come out to turn out as a positive. That means my expression will ideally be lambda times negative x exponential minus lambda x over lambda from 0 to infinity minus 1 over lambda. Now, instead of minus 1 over lambda, if I remove the negative to come outside, to multiply the negative it's outside, I'll have a positive instead. So plus 1 over lambda times the integral from 0 to infinity of exponential minus lambda x dx. And I can integrate this function because it is only one function of x. So let's integrate this function to find out what it is. It means my expression becomes lambda multiplied by minus x exponential minus lambda x over lambda all the way from 0 to infinity plus 1 over lambda. And if I integrate that function, I will have exponential minus lambda x over lambda times negative all the way from 0 to infinity as well. Like that. So now I do not have any integrals to take care of. What I do need to take care of is these limits. So we first of all have to put infinity and then minus when we put 0 in place of x. So for example, in our first case, we'll have lambda. When I place in place of x infinity, I will have negative infinity times exponential minus lambda times infinity over lambda. That when you put infinity minus when you place 0 inside your integral. So this minus, when I place 0 instead, I have negative 0 times exponential negative lambda times 0 over lambda. And this will be for this first part. So for the second part, I also have plus, these are 1 over lambda outside. We'll have to open our brackets. We first of all place negative infinity inside it, so that, sorry, we place infinity inside, so that we have negative exponential minus lambda times infinity over lambda, minus when I place inside 0, minus when you place inside 0, remember there's still a negative you have to carry there with the exponential over lambda. And that's how the expression looks like so far. But as long as the expression is, a lot of things can be cancelled out within our expression. For example, we know that negative 0 times this, whatever this value is going to be here, because it's being multiplied by 0, the result for here will simply be 0. Now, for this part that has the infinity, how do you deal with this part that has the infinity? So we have a negative infinity multiplied by something, but let's first of all find out what this will be. Now we are given, it's given as exponential minus lambda times infinity. What will this result be? If I multiply anything by infinity, any positive number by infinity, I simply have infinity. And if it's a negative number by infinity, I therefore have e times negative infinity. However, this can be written as 1 over exponential raised to infinity. And if you raise a number exponential, which is 2 point something, raised to infinity, you simply get infinity. And therefore 1 over infinity we know will be given as 0. It tends to 0. Which means therefore that anything that has this expression will also be equal to 0. So it will be 0 times infinity, which will make this expression here 0. And this expression also occurs here, exponential negative lambda infinity, and we know this will be equal to 0. So we are left with only 1 to determine what that will be equal to. So let's write the progress so far here. So which means our expression has now become lambda times 0 minus 0 plus 1 over lambda, open the brackets, of 0 minus. Now for exponential negative lambda 0, I know that exponential raised to negative lambda times 0, negative this, will be given by negative 0 times lambda, negative lambda will simply be 0, and anything raised to 0 is 1, so this becomes negative 1. So negative exponential negative lambda 0, this whole expression here can be expressed as negative 1. So 0 minus negative 1 over lambda. Now if we go on to now open the brackets, 0 minus 0 is 0 plus 1 over lambda, that's just 0, and the negative will become positive, which means I have lambda times 1 over lambda times this 0 minus 1 over lambda is simply 1 over lambda, which is like saying lambda times 1 over lambda squared. And the first lambda, the numerator lambda, can go with 1 lambda from the denominator, so that you have the result as 1 over lambda, which is as required. Therefore, the mean of the exponential distribution is given by 1 over lambda. Thank you.